What's up, guys? We are making our very last video for IB Math SL. We're talking about section 24D, quantiles or k-values. They mean the same thing. The general idea here is that instead of working forwards to find a probability, we're working backwards to find a value that corresponds to a probability or proportion. So the general idea is that if we are looking for a value, but we are given a proportion or percent, then we're working backwards and we're finding what's referred to as a quantile. Now, we can do this as long as the mean and the standard deviation are given to us. In this particular case, the mean is 70 millimeters, the standard deviation is 10 millimeters, and it says 95% of the crabs have lengths less than what? So we're looking for a length value in order to answer this question. And we're going to be using a calculator function, not the normal CDF like we did in the last section, but we're going to use the inverse normal function, which is in the same menu. It's in the distributions menu, and we'll take a look at that, obviously, when we get to our example. Speaking of that example, it says example 1 here is x is distributed as a normal distribution with a mean of 23.6 and a variance of 3.1 squared. Find k for which x is less than k is 0.95. So in this situation, we have a percentile of 95%, or 0.95, and we're going to find the k that corresponds to that. So I'm going to go to the calculator, and I'm going to go second vars to get to the inverse norm menu. There's the normal CDF we used last class, but we're going to use inverse norm. Now, because the area to the left is 0.95, that's what I'm going to enter in right here. The mean was 23.1. Or was it 23.6? Now I can't remember. I think it was 23.6. If I'm wrong, it's because I couldn't remember the right number there. And the standard deviation was 3.1. Now your calculator probably does not have this last option here, tail, left, right, center. But for this, for this scenario, I'm going to leave mine as the left because that is the default for just about all of them. And then I hit enter and I get 28.7. All right. So that means that the k value, the quantile, is 28.7. In other words, if I have a value of 28.7 out here on my normal distribution curve, 95% of all observations are going to be less than that value. Now, if I'm looking at this problem here, it says we're talking z, the standard normal distribution. It says find k such that z is greater than k is 0.73. So a couple of things here. Because it's a z, the mean is 0 and the standard deviation is 1. And because it's greater than, that means that the area to the left is actually 0.27. So I'm going to go back to my calculator. Second vars to get to the distributions menu. Inverse norm is right here. I want 0.27. And again, I'm looking for a z, so my mean is 0. My standard deviation is 1. Keep it as left. Enter, enter, and I get negative 0.613. All right, negative 0.613 is my k value, which means that I'm about 0.613 standard deviations below the mean. All right, now let's put it to an example where we have an actual application. It says the university professor determines that no more than 80% of this year's history candidates should pass the final exam. Pretty rough, but what are you going to do? The exam results are approximately normally distributed, which is pretty standard for a group of test grades, with a mean of 62 and a standard deviation of 13. Find the lowest score necessary to pass the exam. All right, so that 80% is the area to the right of my k value, my quantile. So therefore, 20% are to the left. So I'm just going to do inverse norm with 0.2 as my area, 62 as my mean, and 13 as my standard deviation, and I get a k value of about 51.059. And assuming you can't get decimals for your number of marks, we're going to say that you have to have at least a 52 in order to pass the exam. Now, sometimes you're not given all the information. Sometimes you don't know what the mean or the standard deviation is. If that's the case, as it says up here, we must convert to z-scores. You convert to z-scores using inverse norm, just like we did before, and making sure that you enter a mean of 0 and a standard deviation of 1. So, and then once you have that z-score, then you can go to the z-score formula, which is z equals the observation, the x value, minus the mean divided by the standard deviation. So let's look at this example here and see if we can understand what's going on. It says an adult scallop population is known to be normally distributed with a standard deviation of 5.9. Okay, so the standard deviation is given. That means the mean will not be given. It says here 15% of scallops weigh less than 58.2 grams. So we have some information about it. We just don't know the mean, and that's what they're asking us to find here. So we start off by doing inverse norm, the area being 0.15. The mean is 0 and the standard deviation is 1 because, again, we're finding the z-score. That ends up being a z-score of negative 1.0364. Then we set that equal to the z-score formula, which is the observation, 58.2, minus the mean, which we don't know, so we leave it as mu right there, and we divide by 5.9, which is the standard deviation. And then we just algebra to end up getting the mean is 64.3. And you should always do a little common sense check to make sure that your answer makes sense. Our value here, 58.2, the mean is 64.3. Yeah, that kind of makes sense there because it's a little bit more than what the value is that we had. Now, in our last example here, we're in a different situation because both the mean and the standard deviation are unknown, but we have two different pieces of information that will allow us to find both of those. We're going to end up finding z-scores for both. Then we're going to set them equal to the z-score formula, and we're going to, at that point, have a system of equations which we can solve just using algebra 1. All right, so here with the first one, probably that x is less than or equal to 20 is 0.1. I'm going to do inverse norm. The area is 0.1. Mean is 0, standard deviation is 1. And when I do that, I get a z-score of negative 1.282. For the second part, it's the probability that x is greater than or equal to 29 is 0.15. Inverse norm, 0.85, again, because that's the area to the left. Mean of 0, standard deviation of 1, and I end up getting a z-score of 1.036. So I have two equations, I have two unknowns, and I just solved the system. Specifically, what we would do is we would solve for sigma, the population standard deviation, in both equations, and then set the two equations equal to each other and find the mean. And then once we have the mean, plug it back in to get the standard deviation. When we do so, we get a mean of about 25 and a standard deviation of 3.88. That's it. We're all done with our new content. We are going to review this chapter, and then we'll take a test on this chapter, and then we'll talk about what we're doing after that. For the assignment, I'd like you guys to work on page 644, numbers 1 through 9 odd, and 646, numbers 1 through 7 odd. Hope you guys are well, and I'll talk to you all soon.